Morning, students. So today we are going to discuss about the first chapter of Module 4, IEEE 802.11 Wireless LAN Security. So Module 4 contains totally 5 chapters. Starts with the IEEE 802.11 Wireless LAN Security. Second chapter is the viruses, worms and other malware. Third chapter is the firewalls. Fourth one is intrusion, prevention and detection. And finally, this module ends with web security, service security. So coming to the first chapter, chapter 1, IEEE 802.11 Wireless LAN Security. The content of these chapters are background, authentication, confidentiality, and integrity. So before going to the background of this, so here we are interested to carry out wireless networks. And when you are interested to carry out the wireless networks, you need to face few challenges in the area of security, because wireless network is in the form of open nature. Hence, it's a challenges with respect to the security. So we need to look after what are the parameters, what are the precautions we need to take in order to provide security. So usually we have two types of the networks, wired network and wireless network. In the many organization, the wired network is nothing but it's an Ethernet LAN with an existing security infrastructure that includes authentication servers, which is shortly represented as AS. And wired networks carries three functionality. One is the authentication, second one is the authorization, and third one is the accounting. They are going to verify whether the users are valid users or not by using the authentication. And once they are authenticated, they are going to certify, they want to check whether they are certified by the certified authority or not. That is called as the authorization. And once the authorization is completed successfully, they will be counted in the count. Hence it is called as accounting. So these are the three functionality which are provided by a server called as a Radius server. So Radius stands for Remote Authentication Dial-in User Service. So this is about wired network. When you come to the wireless network, so usually wireless networks broadly classified into two types. One is the ad hoc networks and second one is the infrastructures wireline LANs. Ad hoc networks are nothing but where the stations communicate directly with each other. I will tell you what is station and other things. Here, try to understand in a simple way. Ad hoc networks are nothing but stations communicate directly with each other. Whereas in infrastructure, in this concept, stations are going to use access point. You can observe here. So this is the figure representing infrastructure's wireless LAN. So in this figure, what is the observation? We have three computers. So all these computers are connected together through a point called as access point. And all together, the computer along with the access point, this forms a basic service set 1. So similarly, we have two computers here. These two computers are connected to access point 2. Again, it forms another set called as basic service set 2. So now this basic service set 1 and basic service set 2, they want to have communication in the form of wireless LAN. So that is possible through a server called as Radius server. So that concept they explained here. And access point is one which holds the information of all the computers which comes under this set. And similarly, access point 2 holds the information about the computers which comes under service set 2. And the communication between these two sets is possible because of extended service set. And we have one more set called as SSID, stands for service set identification or identity, so which is of length 32 bit. And access point usually act as the bridge between wireless LAN and existing wired network. So this is about the infrastructure's LAN. And here we have listed out what are the differences between AP, access point and station. Here access point or something, but this can be done by monitoring the wireless medium for a special kind of frame called beacon, which is periodically broadcast by the access point. So stations may send a request frame which probes for the access point within the range, and beacon usually uses SSID of the broadcasting AP. And here, so this beacon probe response frame contains SSID of the AP and also information about its capabilities, supported data, and other things. And every station is going to have association with the AP. So a station that wishes to associate with AP sends a request called as associate request frame. And similarly, when there is a request from station to AP, so immediately after receiving the request, AP also gives response. The response is called as associate response frame. So we understood that there is a communication between a station and AP. A station is going to put a request to AP through associate request frame, and AP is going to give a response for that request through associate response frame. So the earliest protocol which are help in security in wireless Wi-Fi was, we have listed out 3 protocols. One is wired equivalent privacy. Second one is Wi-Fi protected access, which is shortly represented as WPA. And third, WPA2. WEP stands for wired equivalent privacy, which is designed to provide authentication or access control, data integrity and confidentiality. But these 3 things, that is providing the authentication, having access control, and having data integrity and confidentiality, fails in some situation. To overcome this drawback, we are going to use one more protocol called as Wi-Fi protected access protocol. So which is going to fix the shortcoming of the wired equivalent privacy. But again, WPA is also not perfect. So it is not able to suspect the attacks in the cryptographic algorithm. So to overcome the problem of WPA, we have one more protocol, which is a highly efficient protocol. This protocol is called as WPA2 protocol. Usually it is used in IEEE 802.11i. So next concept of this chapter is authentication. Authentication includes various kinds of authentication, and every time we need to understand what is the drawback of the authentication type. To overcome the drawback of this particular authentication type, we need to extend one more authentication type. So first authentication type is pre-WEP authentication. So this authentication has several drawbacks. So first drawback is an attacker could easily sniff the value of SSID from the frames such as beacon. Second one is he can restrict the admission to the wireless LAN by MAC address. The access point would maintain a list of MAC addresses. Valid MAC address could be obtained by sniffing the wireless medium. The attacker could access the information, he can go for modification. All these are possible under this particular authentication. To overcome this problem, we thought of using authentication by using one more protocol called as WEP. So this WEP includes access point, and it also uses a concept called as challenge response protocol. So you know the access point generates a challenge. How it is represented challenge? The number is only once, and it sends that information to the station. The station encrypts a challenge and sends it to the access point. So later the cipher, what it is obtained, it is used for encryption purpose. Once the request is over, then again response from the station is also there. The station computes a key, which is a function of 40-bit shared secret key S with a combination of 24-bit initialization vector. The challenge is then XORed. We are going to do XOR operation with the key stream to get response. Here we have shown how response is represented. Response is equal to challenge is XORed with key stream, where key stream is a combination of secret key S and initialization vector. So it seems to be a very good method of using the protocol for providing the security, but again it has drawback. All the attacker need to monitor all these challenge and response pair, and they can get the information of key stream. Again, authenticator himself will need to carry out the XOR operation, which takes more time, and it is possible for the attacker to obtain the secret key S itself. And if it is not possible to attack or access the information, the attacker can refer dictionary attack concept to obtain secret key. So to avoid this drawback, we thought of using one more concept called as authentication and key agreement in 802.11i. I is the common version. So authentication uses 802.11i uses this particular protocol to provide the authentication at the link layer. There are 3 entities. One is the supplicant, second one is the authenticator, third one is the authenticator server. So to have the communication between the supplicant, authenticator, and authentication server, we are going to use extensible authentication protocol called as EAP protocol. So this is the protocol standardized by IETF. So today I will complete the presentation. Tomorrow we'll start with the next concept.